Dear students, I hope you have seen the separate videos on limit comparison test, ratio test, root test, RAPS test, limit Leibniz test, and also one video I recorded for the definition of absolute convergence and conditional convergence. In this session, I would like to say how to decide which test is applicable in what particular situation. Now, I have picked up some questions which are very important from the examination point of view. Let us discuss one by one. So, in this first case, you can see that it is having first one factor. Then there are two factors. Here there are three factors. The number of factors are increasing. Whenever the number of factors are increasing and it is not fixed, the best choice is ratio test. So, you have to go for ratio test in this case. Here you see that there are two factors and there are two factors in the denominator. Even if there are three factors in the denominator, two factors in the numerator, it is going to be fixed. So when you are going to substitute n value 1, it is going to become two factors here. And even in n is equal to 2 case, the values will be different, but there will be only two factors in the numerator, three factors in the denominator. You don't have increasing factors. Okay, I mean to say factors are fixed, only two factors in the denominator and two factors in the numerator. If that is the case, then the choice and the best choice is limit comparison test. I'll come one by one. Okay, limit comparison test for this one, ratio for this, limit comparison test for this. And here you see the factorial. Whenever the factorial appears, the best choice is ratio test. And when the power is in terms of n, then you apply root test. And for this fifth and sixth, be careful that it is corresponding to alternating series, minus 1 to the power of n, minus 1 to the power of n minus 1. Okay, so I'm sorry, I'll write that n here, it was missed in that one. So now for these two, the working style is, first we will remove this part and we handle with this part, that is sigma 1 by n square plus 1 for this one, and for this we handle sigma 1 by n. So without taking this plus minus, we are making all of them positive. It is like we are taking the modulus of that an, and then that is going to become this. If I call this as sigma an, then this complete is going to become an. And if I calculate sigma mod an, then minus 1 to the power of n will create minus or plus, but in modulus all of them will be positive, so we will be getting this one. So let me reverse back all these things. So last two we have to deal with the care. First we have to take the series of all positive terms. It is alternating series and it is also alternating series. From this alternating series we are going to prepare series of positive terms. Once we prepare a series of positive terms, then we categorize the category of that particular convergence, that is a conditional convergence or absolute convergence. Now let me go back to the first problem. So let us deal with solving 1 by 2 into, so let me solve for the first one. Given series can be written as, given, I'm writing the solution with the first one, given series can be written as sigma n is equal to 1 to infinity. You can see that the next fourth term, okay, I'm coming back to this first problem, this is very important. So the next term will be 1, 3, 5, 7. So definitely every term is going to start with 1. So 1, 3, 5, 7, so on up to, what is the nth term of this one? This is a arithmetic progression. A value is 1 and d value is 2. So you can very easily set it a plus n minus 1 into d, that will come as 2n minus 1, and divided by this 2, 4, 6, so on. It is a value 2 and d value 2, so it is going to become 2n. So into x to the power of n, because for the first term it is x power 1, you can see here, and for second power it is x power 2, then it is x power 3. So for n value 1 it is x power 1, for n value 2 it is x power 2, for n value 3 it is x power 3. So with this much of idea implies un is equal to 1, 3, 5, 7 so on up to 2n minus 1 divided by 2, 4, 6 so on up to 2n into x to the power of n implies un plus 1. Here this so on concept, okay, 1, 3, 5 so on, this so on makes the factors to increase, okay, first one factor, then two factors, then three factors, like that. So ratio test to be applied. If the number of factors are fixed, then limit comparison test to be applied. Back to the point, un plus 1 will be equal to 1357. In the place of n, I am substituting n plus 1. So it is, on simplification, it is 2n plus 1. Before that, 2n minus 1. I discussed this in the video where I explained about ratio test. So it is 2n plus 2 into x to the power of n plus 1 implies un plus 1 by un is equal to, now you can see that all the terms will get cancelled except the remaining thing is that 2n plus 1 divided by 2n plus 2 into x to the power of n plus 1, and here x power n comes in the denominator, x power n gets cancelled, so 1x is remaining. Now this is the value of un plus 1 by un. Therefore limit n tends to infinity, un plus 1 divided with un is equal to limit n tends to infinity. Instead of writing like that, I am just dividing with n. So 2 plus 1 by n by 2 plus 2 by n into x. X is a constant. So that's some positive number x. We don't know what the value of x. That x comes out. And the limit is separated. So 2 plus 0 divided by 2 plus 0. That is equal to finally x. We do not know about x. If x is less than 1, then this limit is less than 1. Then given series is going to become convergent. If x is greater than 1, then given series is divergent. If x equal to 1, ratio test fails. But un is going to become, un is going to become 135 so on up to 2n minus 1. When x is equal to 1, we are talking about 135 so on up to 2n minus 1. I am not writing x because x is 1. 246 so on up to 2n. Then un by un plus 1. I am taking now from this calculated work. We have here, I am going to show that one here. This un by un plus 1 by un is ready with that. So when x is 1, this is not there. Therefore, what I now get is 2n plus 2 by un plus 1, reverse of this one. So I get 2n plus 2 by 2n plus 1. 2n plus 2 divided by 2n plus 1, and we apply Raps test. Therefore, limit we will calculate for n times of un by un plus 1 minus 1, that is equal to limit n tends to infinity, n times of 2n plus 2 divided by 2n plus 1 minus 1, and this on simplification is 2n plus 2 minus 2n minus 1, so it is only 1 multiplied to this n, so it is n by 2n plus 1, and if I separate it by dividing with n in the numerator and denominator, I get 2 plus 1 by n. that is equal to 1 by 2 plus 0 that is equal to 1 by 2, it is less than 1, and as per rabbits it is going to become divergent. Therefore, if x is equal to 1, then given series is divergent. Given series is divergent. Hence, we will conclude now in all cases. Hence, given series is convergent if if x is less than 1, and divergent if x is greater than 1 as per ratio and x equal to 1 Rabs applied, and as per Rabs this is divergent. Therefore, it is divergent in both the cases when x is greater than 1 and when x is equal to 1. So we have finished discussing this particular question number 1. Now we come up to this second one. Second one is so simple, pretty simple. That is nothing but 2 factors in the numerator fixed. There is no so on. It is just n into n plus 1. It is 2n plus 1 into 3n plus 1. How many factors are there? They are fixed. They are not going to increase. And hence, that is limit comparison test. Coming to third, it is ratio test. It is root test. Now we will deal with the alternating series. We will deal with the fifth one and the sixth one. So now I copy the question. Fifth one, sigma question, test the convergence of the series sigma n equal to 1 to infinity minus 1 to the power of n or n minus 1, one and the same, 1 by n square plus 1. One and the same in the sense convergence will not change. If it is convergent, it will be convergent. If it is divergent, it will be divergent. That will not change the nature. Whether the starting term is with negative value or the positive value, the difference is just the total final quantity will be same, which is absolute value. Absolute value will be same. Back to the point. So this particular, now given series is sigma n equal to 1 to infinity minus 1 to the power of n minus 1 into 1 by n square plus 1. I call this simply complete as sigma an. Means I call this complete as just an. Implies an. A small change in the terminology I am using, that is an I am using, minus 1 to the power of n minus 1 by n square plus 1. Therefore, sigma mod an is now going to become sigma mod of this complete value minus 1 to the power of n minus 1 into 1 by n square plus 1. And this is just going to become sigma 1 by n square plus 1. Now this is a series of positive terms. Series of positive terms, and you know very well that we have seen this in the earlier how to deal with the positive term series. Numerator is 1, it is a constant. Denominator is a polynomial. So let us say 1 by n square plus 1 is equal to sigma un, say, as we have done in the case of positive term series. Implies un is nothing but 1 by n square plus 1. So when it's a polynomial in the numerator and the denominator, the idea is to generate Vn from Un. So what I now do is 1 by, I take n square common in the denominator. There is nothing, no power of n in the numerator. I think you just simply understand that case, okay? So 1 by n square. Now this value which is coming out as a power of n, I will take as Vn. So let Vn is equal to, I'll change the color and write 1 by n square. This 1 by n square I am selecting as Vn. Then limit n tends to infinity, un by Vn is equal to limit n tends to infinity. When this complete quantity and this complete quantity, this is un, this complete is un, this is Vn. So if I cancel this one, I am left over with only this remaining part. So I write it like This is completely gone. So only this part is remaining. That part I will copy now. 1 by 1 plus 1 by n square. And you all know we are right now revisiting. This is nothing but the revisit of limit comparison test. So limit is applied to this one. I will now directly substitute the value of the limit. So that is equal to 1 by 1 plus 0. This is 1. This should not be equal to 0. That is our requirement. Therefore, by limit comparison test given series, not given, okay, limit comparison test, sigma un and sigma vn both converge or diverge together. Converge or diverge together. But we know about sigma vn. I'll change the color. But sigma vn is equal to sigma 1 by n square is convergent. As per p test, p value is equal to 2 and it is greater than 1. Sigma vn is sigma 1 by n square, that is convergent. Therefore, sigma un is also convergent. Convergent implies sigma 1 by n square plus 1, that is nothing but sigma mod an is convergent. When sigma mod an is convergent, be careful, this is very important point, I am highlighting that one. Sigma mod an is convergent, then we conclude, we say that given series is absolutely convergent, because the absolute value is convergent. You know that mod x is also called as the absolute value of x. So when it is absolute value convergent, we are going to say that it is all given series is absolutely convergent. Now comes the last issue, that is very important here, that I would like to say. If sigma mod an is convergent, this is one possibility, and the other possibility is sigma mod an is divergent. If sigma mod an is convergent, declare that it is absolutely convergent. If sigma mod an is divergent, then check how is sigma an as per Leibniz test. If Leibniz test is saying that sigma an is convergent, then declare that it is sigma an is conditionally convergent. Be careful, start up with sigma mod an. Let me write it. Sigma mod an is okay, let me make it clear here. Whenever there is a problem given of alternating series, what you do is first you calculate sigma mod an. If it is convergent, declare that it is absolutely convergent. This is very easy way. So first you try that way, as we have done just now in this problem. So sigma mod an has come convergent, therefore it is absolutely convergent. If sigma mod an comes as divergent, if it comes as divergent means sigma mod an is divergent. At that time we have to also extra show that it is, we have to do some extra work by using Leibniz test. We have to prove that it is convergent, and then we have to declare that it is conditionally convergent. Let us do this problem now. Sigma minus 1 to the power of n minus 1 into 1 by n. Now n is equal to 1 to infinity. This is sixth problem, I believe. Now, so here in the solution, sigma n equal to 1 to infinity minus 1 to the power of n minus 1 into 1 by n, we call it as sigma an. Implies sigma mod an is equal to sigma 1 by n. Sigma mod an is sigma 1 by n is divergent by p test, p value equal to 1. Now after applying the mod means taking all the terms positive, it is becoming divergent. But how it is with alternating terms, let us see now. But this 1 by n, if I take as un, okay, I'll write it better. But un is equal to 1 by n gives a decreasing sequence of positive terms and limit n tends to infinity, un is equal to limit n tends to infinity 1 by n is equal to 0. Therefore sigma, or I'll write the reference first, therefore by Leibniz test, sigma minus 1 to the power of n minus 1 into un, which is nothing but equal to sigma n equal to 1 to infinity minus 1 power n minus 1 into 1 by n, that is nothing but sigma an, is convergent. Hence the situation is very important to be taken here. Hence sigma an is convergent, but sigma mod an is divergent. You can see here that I have taken this complete as sigma an and I have just shown that sigma mod an is divergent. And after that, using the Leibniz, I have shown that sigma an is convergent. So sigma an is convergent, but sigma mod an is divergent. Therefore sigma an is conditionally convergent. I hope you have understood.